So for 0 to 3, what was the velocity? For 0 to 3, what was 30t squared? And what was the position function? 10t cubed. Okay, that's good. So then let's talk about from 3 to where? What was the velocity? One person read it. What is it? Negative 9.8 what? Yep. Plus? Thank you. And what was the position function, Bill, for negative what? What was the position function for this? Negative 2.8? Negative 9.8 over 2 t squared, yep, plus 299.4 t, yes, and what was the last number? 84.1, is that correct? Okay, so before we go on, I just want to check one report here. Go back to recording. So right here, what do we know? This is the velocity at the end of the last one. The v at 3 was equal to what? 270, exactly, right. So therefore, we know that right here, we take that we know v of 3 is 270. So 270 is equal to negative g times 3 plus c, correct? So if we actually do this out, we're saying negative g is what? Negative 32, right? So we have 270 equals negative 32 times 3 plus c. So what's c going to equal here? 270 plus 96, so that's going to be 366, correct? That's a nicer number. There's no decimal. Yeah, the decimals tend to collapse. So what do we end up with? So now we know that that's c, so therefore we know that v of t for this section is equal to negative 32t plus what? 366. Do you agree with that? Yeah, this is going to be a little bit cleaner. So that's our velocity. So now we move on to the position. So how do we get position from velocity, Killian? Yeah, you anti-differentiate. So you get s of t is equal to negative 16t squared plus 366t plus, we'll call it d. But we know the position at the beginning of this time interval has to be equal to the position at the end of the last one, right? So let's do this again. We'll take this green here. We know from here that s of 3 has to be what? 10 times 3 cubed, which is what? 270, right? So therefore we know that s of 3, so 270 is going to be equal to negative 16 times 3 squared plus 366 times, can you guys take out your calculators, please? Plus d. And that tells us that d is equal to what? D is equal to 270 plus 9 times 16 minus 366 times 3. So what does d equal on this? Negative 684, is that correct? Yeah. Okay, so what does that tell us about the position function? Our s of t is what? Negative 16t squared plus 366t minus what? 684. Okay, so we now have the position function here and we have the velocity function. So that's for our second time interval. So we're back to where we were before, but with numbers that should help us actually get something that makes sense. Okay, so now we're looking at the next 5 seconds, I think it is. Is it the next 5 seconds?
Yeah.
Okay, we'll go to black here. So it's from 17 to 22. What do we know? The parachute is open, right? Mm-hmm. And it has a constant, there's some acceleration, a of t on this. There's some constant deceleration, right? And we'll just call that a, correct? We know it's some a value. We know that after 5 seconds, we know that the velocity at 22, what's the velocity at 22 going to be? Negative 18, correct? And we know it's going to be a constant deceleration, right? So we need to know what is the velocity at the beginning of this time interval. What's the velocity at the beginning? So we find the velocity at, well, that's at the end. It slows down to this. It slows down to negative 18. So we look at velocity right here. We use this velocity function right here. the beginning would be what's the time at the beginning of this interval. So v of 17 is going to be equal to negative 32 times 17 plus 366. Can you tell me what that is? What's v of 17? Negative what? Do you get negative 178? Yeah, these are going to be a lot bigger because instead of negative 9.8, we're dealing with negative 32. So the numbers are just going to be triple. Oh, anyway, so that's what it is at the beginning, but it goes from negative 178 to what? Negative 18. Now, why does it slow down in terms of how fast it's falling? Because what opened? The parachute. It's slowing it down, right? It's slowing it down. It better, or it's going to break when it hits the ground. And then, so look, at 17, it's at negative 178, correct? But at 22, it's negative 18. You want to find the constant deceleration. So what do you have to find between these 2 points? The slope. So you know that you're finding the slope from time equals 17 to time equals 22. So what's that going to be? It's going to be negative 178 minus negative 18 over what?
17 minus 22.
Ah, did I do that the wrong way? Yeah, I did it the wrong way. Yeah, I reversed it. So you got negative 18 minus negative 1. It's not going to matter, I understand, but I'm trying to keep it constant here. Over what? 22 minus 17. So what's that going to be?
32.
It's going to be, what, 160 over what? 5. So it's going to be what? 32. Okay, so we know that the constant, it's actually accelerating in a positive way because it's slowing it down. It's slowing it away from the direction it's going in is...
Oh, wow, what a nice number.
What a nice number. Yeah. Was this a generated problem?
Yeah.
Maybe. It might have been a generated problem. Okay, so what does that tell us? It tells us that for this interval, the acceleration is 32. It's pulling it up, essentially up away from it's falling at 32 feet per second squared, because the rate of change of velocity is what? Is acceleration, correct? It's negative 178 minus 32 times 17. Negative 178 minus 32 times...
544.
What's C equal to?
I had the wrong.
Negative 178 minus 32 times 17.
Negative 622.
Negative 622?
Yeah,
Okay.
I was wrong.
It's negative 722. Figure out what's wrong. It should be negative 722.
Yeah, it's
Yeah, negative 722. Okay, so what does that tell us the velocity function is then? V of t is equal to 32t minus 722. Now, why is that so negative? Because it's falling when the parachute opens. It's falling when the parachute opens. If we do this right here, just to check this out, let's just check this. What's V of 22 on this? 32 times 22 minus 72. Can someone tell me what that is? Do it on your calculator. What does that come out to be?
Negative 18.
I hope so. What does it come out to be? So does that check? Is that exactly what we wanted? That's exactly what we want. Okay, so that's the velocity. What else do we need now? We need the position. Okay, so we integrate. We get S of t is equal to 16t squared minus 722t plus d. But the position at the beginning, Matt set up, the position at the beginning of this has to be equal to the position at the end of the last. Why? You can't teleport. Yeah, there's no teleportation. You can't go, whoop, oh, gone. Okay. I'm so going to write a calculus problem with teleportation. It's going to be awesome, and it's going to break you. Okay, so we need to find the position at the end of the last one, right? So on this one, I'll draw this nice. Let's go back to green here. So we take this one, S of t right here. So S of, what's the beginning? It's S of 17, right? So what was S of 17? It's going to be negative 16 t squared, right? Is that correct? Negative 16 plus what? Plus 366. Oh, wait, instead of t, what do you have to write? 17. Keep in mind, I'm using this one. This is the position function for the last one. Plus 366 t. Not t, what do I write? Plus d. Can someone tell me, three of you, at least three of you, find me what d is, please. Or now what can we set up? 914 is equal to 16 times 17 squared minus 722 times 17 plus d. Now, can you find d for me? It's going to be 914 minus 16 times 17 squared plus 722 times 17. Can someone do that for me? What does d equal? What does that tell us the position is? S of t is going to be equal to negative 18t plus what? 424. So this is the position function of the last one, right? No? Oh, I'm totally wrong. I'm sorry. I got really excited that we were at the end, and we're not. 424 is equal to negative 18t plus times what?
22.
Times 22. So what's c equal to?
790. 820.
424 plus 18 times 22 is what? 820. Yes, thank you. So therefore, what is our final position function going to be? Negative 18t plus 820. Okay. If we were going to graph a simple piecewise function, let's say we want it to be y equals x squared was one of our functions. Let's say we wanted, I don't know, negative 2x to be another part of our function. If we just graph this, let's do zoom standard. Hey, there's x squared and there's negative 2x, right? Let's say we wanted it to be just the left-hand part of negative 2x and the right-hand part, so to the left and to the right of the y-axis. What you do here is you go to the x squared and you literally say parentheses x, and I think it's under math. Where is it? It's the greater than sign. Where is it? It's under, anybody remember? Second math?
Yeah,
Oh, it's
second math.
test. That's right. I'm sorry. It's under test. I always forget where it is. It's second test right there. X greater than 0, like that. And if you want negative 2x to be less than 0, you literally just do this. X test less than 0. And now when you graph this, look what happens. Zoop, and just the left-hand side.
Oh, that's cool.
Now here's the thing. Sometimes you might want to do a compound inequality, like limit it between like 1 and 2. When you do that, you can't write a compound inequality right there. You literally have to do this. Let's say we want to be greater than 0, but x is also less than, I don't know, less than 3, like this. Look what happens. It's going to go all the way to, well, actually, you're not going to see it because let's change it to x is less, you kind of see it. Let's make it a little better here. Less than 2. You graph this. It should stop at 2. You can't write a compound inequality. You have to write them separately. It's something that is really annoying at first. You can't figure out why it's doing it, and that's how you do it. Does that make sense, everybody? So I'll clip that in. So find its derivative, set it equal to 0. So this is the position. This is the position for which time interval? This is what, 0 to 7? No, sorry, 3 to what? 3 to 17. Is that correct? 3 to 17? Like that? So what do? You find the derivative. So what's s prime here? Oh wait, do we already have s prime? Yeah, what is s prime? Oh, it's already up here. What is it? It's the velocity. We already have it, right?
Yep.
So you take this right here. So that's the velocity of the second one, which we already have. Oh, look at that. We already have it. Even put it right there, right? We want that to equal what? So 0 is equal to negative 32 times t minus 3 plus 270. So 0 is equal to negative 32t plus 96 plus 270. So we know that 32t is equal to what?
366.
So t is equal to 366 over 32, which is what? The minus 3. Oh, this is just how they wrote. Remember I said they wrote things in factored form? So look, if we write this out, it's negative 32t plus 360.
Not a nice
I know I never said it's going to be nice, but it could be worse. At least it's rational, right? Look, Tina, you wanted this, right? That's what we wrote instead. They like to write it in this factored form right there. So what is it? 11 point what?
4.375.
75. Okay, so that's when it reaches its maximum height. What is its maximum height? You then take this and you plug it into the position function. So you do s of 366 over 32. Do that out for me and tell me what the maximum height is. Last one to equal what?
0.
0. So you want to know when 0 is equal to it lands, right? We're doing landing right here.
820 divided by
Landing is going to be negative 18t plus 820. So it lands at t equals 820 over 18. So what is that? It lands at what time? 0.55? Like that? Yeah. Good. So that's actually the easiest one. So the bulk is in the beginning. So let's record this. So what do we end up with? We end up with 90 times 5,280 over 3,600
equals 132.
equals what?
132.
Is it exactly 132?
Yeah.
So this is 132 what? Feet per
second.
feet per second. Exactly. Exactly. So
That was very nice of them.
that's very nice of them. Exactly right. So what does this say? It says it gets to its cruising velocity, which is 132 feet per second. How long is it going to take to get there, right? So the question is, 132 is equal to 4 times time.
33 seconds.
So what's it going to be?
33 seconds.
33 seconds. Okay, let's pause this for a second. Think. It's at its cruising velocity for how long?
90 miles.
15 minutes, right? 15 minutes at what? 132 feet per second, right? So
Wait,
15.
I have a question.
Stop 1 second. How many seconds are in that? What?
The 4 was feet per second squared.
So this is the distance traveled when it's at cruising velocity, right? So what's that equal? What is 15 times 60 times 132? Please do that right now. Tick tock, tick tock, tick tock, tick tock, tick tock, tick tock, tick 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 tock, tick 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 tick. What is it?
118,800.
118,000 what? 800 what? Feet. So the total distance is therefore, what's it equal? 2178 plus 18,800 feet. To clarify on the record, the train is stopping between the stations. So we're converting to feet because everything we have is in feet per second squared. So the point is, it's accelerating and it's
Decelerating.
we know it's 33 seconds, right? And we know it's 33 seconds. How far does it go? How far does it go? 2178 feet, right? 21 what? 2178 feet, correct? We don't know the time, right? We don't know the time in the middle, but we know how far it has to go. It has to go 45. Oh, we know how far, but we don't know the time, is what I'm saying.
Yeah.
We know it has to go this far minus what? 2 times 2178, right? This is the distance it has to travel, right? But we don't know how long it's at cruising velocity for, right? But we know that. Oh, do we know what the I'm sorry. We know what the cruising is. What is it? No, let me pause this for a second here. What is it? What's that equal to?
1,833.
1,833 seconds total. So that's going to be 1833 seconds divided by 60. Can someone tell me how many minutes that is?
30 and a half.
30 point what?
30.55.
30.55.
You know they could save half a minute if they didn't stop.
Yes, apparently they could save half a minute if they don't stop. Okay, so it's 30. Does everyone understand how we did that right there? The key thing that we figured out already, the hardest part was we know it takes 33 seconds and it travels 2178, right? So it's 33 and 2178. So we know, this is actually irrelevant. We just need to know the distance, right? We just need to know the distance. We already know the time. That comes in at the end. So we know that's how many feet it has to travel. Distance divided by rate is going to be equal to time. Distance divided by rate is equal to time. So we got the time at cruising. This is the time accelerating, decelerating. So the total time is 1,833 seconds. All right.